Hello and welcome to today's lesson on similarity and congruence. This is going to cover topics in the standard 4.2 in geometry, and then also the study island lesson. It's going to go over questions in the study island lesson called similarity and congruence. So this is very similar to the other lesson we did on flat shapes, so like triangles and parallelograms, only now we're looking at the 3D shapes, so prisms, pyramids, cones, those types of shapes. So the same rules are going to apply. Congruence means they're exactly the same, and similar means that they are the same shape, but they're different sizes. With those similar shapes, we can set up proportions to solve just like before, only now we have to remember that when we're looking at their areas, we're going to remember that we're going to need to square, since area units are always squared, and when we're looking at their cubes or their volumes, we're going to have to remember to cube, because since volume units are always cubed. So I highly encourage you to take notes. You can always pause or rewind if I go too fast. And let's go ahead and look at some notes on congruence. So like I said, solids that are congruent are going to have the exact same shape and dimension. So these are two congruent pyramids. And so you also know that their areas and volumes are going to be the same as well. So in this first problem, it says a storage unit in the shape of a rectangular prism has a height of 12 feet and a width of 9 feet. The perimeter of the base of the second storage unit congruent to the first is 32 feet. What is the volume of the first storage unit? Well, since you know these two are congruent, you can use the information from the second storage unit to help you find the volume of the first storage unit, because everything's going to be equal. It's all going to be the same. So the volume here, it tells you to take the area of the base times the height. So the area of my base, that's going to be the rectangle. And it tells us that we know the perimeter of this rectangle is equal to 32 feet. And then it also tells us that we know the width of this rectangle is 9. So I know that these two are 9. I need to figure out this other missing side here so I can figure out the area of this rectangle. So I already have 9 and 9, which is 18, taken from this perimeter. So I'm going to take 32 minus 18, which is 14. And then, so I have 14 to divide evenly between these two sides. So 14 divided by 2 is 7. So each of those sides is 7. So then the area of a rectangle is length times width. So to find that, I'm going to take 9 times 7, which is 63. So that means here, when I calculate my volume, I'm going to take 63 times the height of the prism, which is 12, and 63 times 12 is 756 feet cubed. So my answer is going to be C. This problem reads, rectangular prism L has a surface area of 176 centimeters squared. The rectangle prism M has a width of 4 centimeters, a height of 9 centimeters. What is the length of rectangular prism L if though given that the two prisms are congruent? So the moment that I know that they're congruent, I don't have to keep track of which measurements go with which ones, because they're going to be the same. They're congruent, so everything is equal. Everything's the same on them. So it wants to know what is the length. So that means I'm going to fill in everything I was given here into this formula to see if I can then solve for length. So I'm just going to make it a little easier. I'm going to list it out. So they told me that the surface area is 176. They told me that the width is 4 and the height is 9. And it's looking for the length. So I'm going to go ahead and substitute that in. I know surface area is 176 equals 2, and the length is what I'm looking for, times the width, which is 4, plus 2 times the width, which is 4, times the height, which is 9, plus 2, and I'm looking for the length, so I'll just write L, plus the height, which is 9, or times the height, which is 9. So then I'm just going to go ahead and work out some of that multiplication to make it easier. So there's nothing I can do with 176. Next, I look at this term. I can take 2 times 4, which is 8, and this is going to be 8L, plus, next I look at my next term. 2 times 4 is 8. 8 times 9 is 72. Plus, and then I look at my last term here, 2 times L times 9. I can take 2 times 9, which is 18. And then I have 18L. So the next thing I'm going to do is combine like terms. I have 2 L terms. They're on the same side of the equal sign, so I'm just going to combine them like they are. They're going to stay the same because they're on the same side of the equal sign. So that's going to be equal to 8L plus 18L is 26L plus 72, and that equals 176. And now it's a two-step equation. I'm going to subtract 72 from both sides. And that leaves me with 104 equals 26L. And then you divide both sides by 26. 104 divided by 26 is 4. And that's what L equals. And so I have a length of 4 centimeters. My answer is C. So here it tells me a cone has a volume of 1,080 pi centimeters cubed and an altitude of 10 centimeters. Altitude is another word for height. What is the area of the base of a cone that is congruent to this cone? So it wants to know what is the area. So I need to know the radius. It doesn't tell me that, but it does tell me the volume. So I'm going to have to use that volume information to solve for the radius. So it tells me that the volume is 1,080 pi and my height is 10 centimeters. So I'm going to go ahead and substitute these two pieces of information into my volume formula. So I know volume is equal to 1,080 pi, and that equals to 1/3 times pi times radius squared, which is what I'm looking for. So I'm just going to write r squared times my height, which is 10. So then I'm going to go ahead and multiply 1/3 times 10, which is, I'm just going to leave it as 10 over 3 pi radius squared, and that still equals 1,080 pi. The reason I left this as pi here is because there's a pi in this number and there's pi in our answers. And it didn't tell us we could use 3.14. So those are all reasons that I had to leave it exact. Now pi is just a number. So I'm just going to divide both sides by 10/3 pi. And here these all cancel out. And here the pi's cancel out. And when I take 1,080 divided by 10/3, that leaves me with 324 radius squared. And to undo a squared, I take the square root of both sides because squaring and square roots are opposite, so those symbols will cancel. And that'll leave me just with r, and then the square root of 324 is 18. So now I finally know my radius. I can use that in my area formula here to find the area. So I'm going to take area equals pi, and then once again I'm leaving that pi, times 18 squared. Well, 18 squared is 324. Keep the pi there. And that's my answer. Units is centimeters squared. So my answer is B. Next, we're going to look at similar solids. And these are solids that have the same shape and proportional corresponding dimensions. So they're different sizes, but those sizes are proportional. And when you know that they're proportional, that means that everything is proportional. Their surface areas, their an area of a side, the perimeters, the volumes, everything becomes proportional. So, but the thing you have to remember is that when you're dealing with the volume, that volume, the units is always cubed. So when you're setting up the proportions, you're going to have to remember that there's cubing involved. And when the area is always squared in the unit. So you're going to have to remember there's squaring involved. And I'm going to go over some of those examples so you can see what I mean by that. This question here reads, a cone has a volume of 900 pi centimeters cubed. The altitude of the cone is 12 centimeters. What is the volume of a similar cone with a radius is 30 centimeters? So remember, when we're working with similarity, we're setting up all those proportions. And so, but when we have a proportion, we have to have two things that are alike. So here, this one gives us the volume and the radius of the second cone. So we would need the volume and the radius of the first cone. But they don't give us the radius of the first cone, so we're going to have to solve for that using the formula they provide. So that first cone has a volume of 900 pi, and that's going to equal 1/3, and I'm going to keep the pi in there since there's pi in the volume they gave us, and pi is in our answer. And that's going to be times the radius squared, which is what we're looking for, so I write r squared, and then the altitude or height is 12, so I'm going to substitute in 12. So then I'm going to go ahead and take 1/3 times 12, which is 4, just to make this side a little bit neater. So I have 4 pi r squared, and that's equal to 900 pi. Then I'm going to go ahead and divide both sides by 4 pi, because that's what's in front of the r squared. That's what's being multiplied by the r squared. So they all cancel, and then these pi's also cancel. And then 900 divided by 4 is 225. And that equals r squared. So I almost have r by itself. The last step is to get rid of the squared by taking the square root of both sides. The square and the square root cancel. And so I'm just left with r. And then the square root of 225 is 15. So now I know that the radius of that first cone is 15. So I can go ahead up and set up a proportion using the radius and volume of the cones. So my first cone I'm going to put on top, and my second cone I'm going to put on the bottom. So I just wrote those, wrote the 1, 2, R, and V to help me keep everything straight. So the radius of the first cone is 15. And the radius of the second cone is 30. Okay, and that's going to equal the volume of the first cone, which is 900 pi, over the volume of the second cone, which is what we're looking for. So you could put V there, you could put X there, whatever floats your boat. And now we're going to have to go ahead and solve for that X, but this is where you have to remember that since the volume is cubed, because it's units cubed, we're going to have to in order to make these equivalent, we're going to have to cube the radius. So each of these numbers has to be cubed in order for us to use this proportion. So 15 cubed is 3,375. and 30 cubed is 27,000. And so that equals 900 pi over x. So now I can cross multiply. 3,375 times x is 3,375x. And then 900 pi times 27,000 pi is 24,300,000 pi. And then I just divide both sides by 375. And you wouldn't put pi in your calculator unless you're using your calculator does the exact pi symbol. But you can just put this 24,300,000 divided by 3,375, and when you do that, you get x equals 7,200. Then you carry through the pi. And then my units is centimeters cubed, so my answer is C. All right, so number 8 says 2 similar rectangle prisms have lengths of 10 centimeters and 20 centimeters. If the base of the smaller prism has a width of 14 centimeters, what is the area of the base of the larger prism? So here I can go ahead and set up a proportion using the lengths and areas of the two prisms. But that means we need to figure out the area of the smaller prism first, of the area of the base of the smaller prism first. So that's just length times width of the two smaller. So the smaller length is 10 times this 15. 10 times 14 is 140. And so I'm going to have an area of 140, and then I'm looking for the area of the bigger base. So I'm going to put an S and a B over here, just so I remember I'm putting smaller on top of bigger. And so the length of the smaller prism is 10, and the length of the bigger prism is 20. And now I have my proportion set up. But since I am comparing length to area, where length is just centimeters and area is centimeters squared, I have to remember to square both of these so that these two fractions are equivalent. So 10 squared is 100, 20 squared is 400, and that equals 140x. I'm going to cross multiply these. I'm going to take 100 times x is 100x. And then 140 times 400 is 56,000. And then I just divide both sides by 100. And when I do that, I get x is equal to 560. And my units is centimeters squared, so my answer is D. Thank you for joining us today, and I hope you learned something new.